All right, example 5 says factor the expression by grouping. So this is a new type of factoring method. So we have 4 terms. So we want to first see that the polynomial expression is in standard form, which it is. It has the x cubed, the x squared, the x, and the constant. So what we do is we group the first 2 terms together. And then put an addition symbol, and then we group the second 2 terms together. And now what we do is we take out the GCFs of each group. So if we look at this first group, the GCF is going to be x squared. So what's left is going to be x plus 3. Then we take out the GCF of the second group, so we can factor out a -4. So we're left with x plus 3. If you've done this problem correctly every single time, the parentheses will be the same. And we call that the new GCF. So the x plus 3's are the GCF of that expression. So we take out the x plus 3. And then we're left with x squared minus 4. So we've done the grouping by GCF. Then we look inside here in the red. That is factoring by the difference of 2 squares. You can factor that as x plus 2 and x minus 2. And then we still have the x plus 3 as my first GCF. Here's another example of factoring by grouping. So we group the first 2 terms together, x cubed minus 2x squared. Then we group the second 2 terms together. And then we factor out their GCFs. So the GCF of that group is going to be x squared. So you're left, when you take out an x squared, an x from the first term and a minus 2 from the second term. The second group, it has a GCF of -9. So you're factoring out a -9 from those terms. So the first term, after we take out the -9, we're left with positive x. When we divide 18 by -9, we get -2. So now stop and check. Notice that these 2 parentheses are the same. They are now your new GCF. So you have x minus 2. So we take out the x minus 2, and what we're left with is x squared minus 9. Now, just like the last problem, we can factor that by the difference of 2 squares. We have x plus 3, x minus 3. And then we have x minus 2 outside. We're going to go ahead and use grouping again one more time, but now we need to find the zeros, the roots. So we're going to group the first 2 terms together. Group the next 2 terms together. And now we take out the GCFs. So the GCF of the first group is x squared. So you're factoring out an x squared. So when you take out the x squared from the first term, you're left with 2x. When you take out an x squared from the second term, you're still left with the number 1. In the second group, the GCF is 4. So you're dividing both of the terms by 4. So you're left with 2x plus 1. Now at that point, just like the last 2 examples, the parentheses should be the same. They are now your new GCF. So So you have 2x plus 1 as your GCF, and then you're left with x squared plus 4. Now you can't factor that x squared plus 4 because it's not a subtraction sign. It's not the difference of two squares. All right, now we want to find the zeros. So we set the factors equal to 0 and solve for x. We're using our zero product property. So 2x plus 1 equals 0, and x squared plus 4 equals 0. And then we solve them. So the purple equation, we're going to subtract 1 from both sides. We get 2x equals negative 1. Then we divide both sides by 2. We get x to be negative 1/2. So there's our first 0. The red equation, we solve by undoing. So we subtract 4 from both sides. We get x squared equals negative 4. Then we want to undo the squared, so we're going to square root both sides. Don't forget the plus or minus in front of that square root. Then we simplify. X equals, and now notice there's a negative underneath that square root, so that's going to become an I. And then the square root of 4 is 2. So now we have two non-real roots, which we call imaginary roots. So our zeros are negative 1/2, positive 2i, and negative 2i.